Okay guys, so in this video we're going to talk the last video was about the theory of derivatives, and then here we're going to try and put them into practice and try and develop some patterns and prove how to actually start taking some derivatives. So the first thing I wanted to do was to talk about some terminology. So these terms all mean the same thing. So these can all be used interchangeably, one with the other, all sorts of stuff. So we have derivatives, which we defined by saying it was the limit as h goes to 0 of f of x plus h minus f of x all over h. So this equation was our definition of a derivative. This is how we found the slope of the tangent line by just finding the slope between those 2 points and bringing it together. That's the theory. Okay, some other words we can use. Again, we have slope of the tangent line. Sometimes we'll write it as the slope of the curve. And some of the notations we might see, we might talk about it as f prime of x. That's how we represent a derivative. Or dy dx. Sometimes we'll write a derivative like that, or even like y prime. We might also talk about it as the instantaneous rate of change. That's another thing that means derivative. So this idea of like the slope of a curve at some point is fundamental. Sometimes you'll see another form of the definition. It's not as popular as that one, but sometimes you'll just see, again, the limit as x goes to a of the slope between the point x and the point a. But it's the same thing. So whenever you see any of these, they all mean the same thing. They're all talking about that same derivative. Okay, so today we're going to talk about how do we find different derivatives. So I want you to make a little table here. So we're going to have some function, f of x, and then that function's derivative, f prime of x. Okay. And we're going to take derivatives of various things. And at the start, we're going to use the definition to find the derivative, and then later on we'll find some shortcuts and some patterns and that sort of thing. Okay, so first one I'm going to start with is something like 2x. So what is the derivative of 2x? So if I want to find the derivative of 2x, let's use this limit. So f of x, of course, is just the function 2x. So f of x plus h, when you do that, you're saying, let's just plug in x plus h in for the x right there. So this becomes 2 parentheses x plus h. Okay, also known, of course, as 2x plus 2h. So when we go ahead and take this limit, we're taking a limit h goes to 0 of f of x plus h minus f of x all over h. So that just becomes a limit h goes to 0 of 2x plus 2h minus 2x all over h. The x's cancel. This just goes to 2. So what that means is the derivative of 2x is 2. And again, we think of that as a slope. So this is saying the slope of f of x is 2, always. And that hopefully makes sense, right? Because if you think of the graph y equals 2x, it has a constant slope of 2, right? No matter what point you pick along this line, it always has a slope of 2. Okay, so let's leave some room in this table. We'll fill it out later. Next up, what if we had the function x squared? So if you did f of x plus h, so x plus h squared is x squared plus 2xh plus h squared. Okay, oops, sorry about that. So you can see how cheap I am. So anyway, going from there, if we plug into this formula, we have a limit h goes to 0. So this is my f prime. Limit h goes to 0 of x squared plus 2xh plus h squared minus x squared all over h. Okay, so the x squareds cancel. So this becomes a limit h goes to 0 of h parentheses 2x plus h. I just factored out an h from those two terms right there. And then these cancel. Okay, so then as you take this limit, right, you just get 2x plus 0, which is just 2x. Okay, so let's write that in our formula sheet, and then we'll kind of talk about that. So that means the derivative of x squared is 2x. So what that means when we say that f of x is x squared and f prime is 2x, that means that the slope of f at a value x is 2x. So if I write, for example, like f prime of 2, well, f prime of 2 is 2 times 2, which is 4. So what that means is that on the graph of f of x, the slope at x equals 2 is 4. So at x equals 2, we have a slope of 4. Similarly, if I had to find f prime is 0, f prime is 0 is 2 times 0, which is 0. Well, that means that on the graph of f of x, the slope at x equals 0 is 0. And again, this makes sense, right? Because if you draw a parabola, at 0, you have a slope of 0. At 2, you have a pretty big positive slope. It's a slope of 4. If you plugged in -1, you get a slope of -2. And that is, in fact, what we see, right? We have a negative slope on the left side of the graph. So that's what we're talking about with f prime. That's what it represents. It's an equation for the slope at any given x value. So that's how you want to think about this f prime. It is an equation for the slope of f. Okay, so that's useful. Anyway, let's put this in our table. So, we already did. Cool. So let's go on our next function. Let's say we try and take another derivative, f equals x cubed. Okay, I am going to do this in my head. You should really not do this like on paper. Like, don't even write this down. Which turns out to be x cubed plus 3x squared h plus 3xh squared plus h cubed. That's how you multiply that out. So if you take your limit h goes to 0 of this, f of x plus h minus f of x all over h, this becomes x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed divided by h. Okay, these cancel. So we can factor out an h on top. Again, we have a 3x squared plus 3xh plus h squared all over an h. Those cancel. Anyway, you take your limit as h goes to 0, and you end up getting 3x squared plus 0 plus 0. Okay, so again, what that shows, this is our derivative, what we calculated by doing this limit. What that shows is the derivative of x cubed is 3x squared. So again, if you want the slope at any given point, any given value of x, you plug it into this equation, and that will give you the slope. So at x equals 1, your f prime is 3 times 1 squared, or 3. Okay, so some of you might be noticing the pattern or remember it from last year, but when you take the derivative here of x to the n, so one thing you might see is that number there comes down, this number comes down, and you subtract it by 1. So instead of x squared, you have x to the first. Instead of x cubed, you have x squared. So the derivative of x to the n is nx to the n minus 1. Okay, and that's actually true for any n except 0, which makes sense because that's just a constant. So let's go ahead and talk about that. This also works for something like this. So for f equals 1 over x. What you should do is you should write this as x to the nth power. So write it as x to some power. So 1 over x, we know we can write as x to the negative 1. So then the derivative of that, the negative 1 comes down, is negative x to the negative 2, which you could also, of course, write as negative 1 over x squared. Now, you could prove this at limits too. You'll get the same formula, but that does work. Same thing if you have something like, I don't know, the cube root of x. Well, you should write that as x to the 1/3 power. So then the derivative of that is 1/3 x to the negative 2/3. So again, this formula is always going to work no matter what. Okay, some other derivatives you might say, well, what if we have a constant? So what if your f of x is just equal to, I don't know, 3? Well, then f of x plus h, there's no x to plug in, so f of x plus h is also 3. So if we take the limit as h goes to 0 of f of x plus h minus f of x over h, you take the limit of 3 minus 3 over h, which is the limit of 0 over h. Now, it might seem like you get a 0 on the bottom, but because this just simplifies to 0 ahead of time, you just take a limit of 0, which is just 0. So what that says is the slope of any constant like 3 is 0. So if f is 3, your f prime is 0. And again, that makes sense, right? Because if you graph the function y equals 3, right, doesn't that always have a slope of 0? It's a horizontal line, right? The slope of the graph is flat, so a derivative of 0 makes sense. So if you take the derivative, going back to our table, of 2 or 3 or any constant, that has a slope of 0. Okay, let's talk about a couple other derivatives that we're going to note. The derivative of e to the x is actually e to the x. And that's just by definition. E is defined as the number such that e to the x is its own derivative. And the other derivative we need to know for now is the natural log of x. If you love using log properties, you can prove this using limits. But for now, we can suffice it to say the derivative of ln x is 1 over x. Okay, so those are some of the more popular derivatives we're going to use. Let me go ahead and teach you about some rules here, or it's kind of how to solve some problems as well. So some rules. You can pull out a constant. You can pull out a constant. So kind of like with limits, if you try and take, and just because it's limits, the derivative of some constant times f of x is that constant times f prime of x. Similarly, if you have the derivative of f of x plus or minus g of x, so if you have two things added or subtracted, you just take the derivative of each part. So the derivative of those two is the derivative of the first part plus or minus the derivative of the second part. It's something different if they're multiplied or divided. We'll get to that in just a minute. And by a minute, I mean the next video. Okay, so just to kind of give you a couple example problems, I might ask you to find f prime of x if f of x equals 3x to the 10 plus x squared minus 2 times square root of x. Okay, so when you take the derivative, we're going to kind of do this in one chunk. So the 3 stays in front. Just take the derivative of x to the 10. So that's like 10x to the 9. Derivative of x squared is 2x. For something like this root x, you should write that as x to the 1/2 power. So then the minus 2 is in front. So this comes 1/2. Oops. 1/2. And then x to the negative 1/2. Okay. And then just to clean this up a little bit, we could write it as 30x to the 9 plus 2x. Here, the 2 and the 1/2 cancel, so minus x to the negative 1/2. If you're a real nerd, you could write that as like a 1 over square root, but that's fine too. Okay. Here's another example. Suppose I tell you y equals ax cubed plus b over x plus pi times x. Sorry, let's just do plus pi. And in this case, a and b are constants. So you're just going to treat them as if they were a 2 or a 3 or something like that. So the derivative of that, the a stays in front, you bring the 3 down, so that's 3x squared. This is like bx to the minus 1, so the minus 1 comes down, so that's like negative bx to the negative 2. And pi is just a number, right? If we take the derivative of 2 or 3, it's 0, so the derivative of pi is also 0. Okay, some other things you might be asked to do would be to differentiate. So if you have to differentiate y equals, say, 2x cubed plus x plus 1 over x. Okay, so two things about this. First off, when you see differentiate, that just means take the derivative of. There's nothing crazy about that. But when you have something like this, like we don't quite know how to deal with fractions yet. We probably will in the next video. But for now, just kind of split this up. All right, so split this up and just say, I could write this as 2x cubed over x plus x over x plus 1 over x. So basically what I'm doing is I'm simplifying before I actually try and do any derivatives. Now, actually I'll take this one step further. So I'll write that as 2x squared plus 1 plus x to the minus 1. And then your derivative rate is very straightforward. It's just 4x, derivative of any constant 0, and then minus x to the minus 2. Okay. Sorry about that. So that's how you actually can go ahead and take derivatives of something like that. Where it's like a fraction you can easily split up. You're just going to turn it into like something in this form that I can handle and use my power. It's called the power rule. I should have written that before, up above. Yeah. This thing right here where we took the derivative of power is called the power rule. Okay. So we've done that. I want to do one more quick example of a problem you'll have to do. So I might give you a problem like this. So say f of x equals x to the 4 minus 2x plus 5. And I'm going to ask you to write the equation for the tangent line at x equals 1. Okay, so when we write an equation for a tangent line in this class, it's usually going to be in the form y minus y1 equals some slope times x minus x1. Okay, so basically what you need, this m is the slope of the tangent line. And what's the slope of a tangent line? That's a derivative, so we need to find f prime of 1. To find the point is x1 comma y1. So to find the point, we need the y value at 1, so we need f of 1. Okay, well that should be pretty easy, right? F of 1 in this case, I just plug in, it's 1 to the 4 minus 2 times 1 plus 5, which is 4. So if I'm trying to find f prime of 1, well, let's find f prime first. So always a good example. Okay, so one thing we should also point out is that you're going to take the derivative first and then plug in 1. So you always take a derivative before you plug in a value. So when I take the derivative first, I'm going to get 4x cubed minus 2. So then when I find f prime of 1, I'm going to get 4 minus 2, which is equal to 2. Okay, so now I'm actually done. I know the problem, I know the x value, I know the y value, and I know the slope. So now I'm going to plug these all in and put it together. So I have the point here, I have the slope here. So I'll write this out as y minus the y value 4 equals the slope of 2 times x minus 1. And that's what you do. We're going to see a lot of these problems here where they ask you to find the slope of a tangent or the equation for a tangent line. And just remember the slope's the derivative and the point's the y value. Okay, so that was this video. A lot of good stuff in here. Thanks for watching. I'll see you guys soon.